Today is the 16th of November 2023, and would like to continue with Pythagoras Theorem. Before I begin, as usual, please, thank you to everyone who has been watching our videos. I appreciate it a lot. If you haven't subscribed already, please, can you subscribe, follow, like, and share our videos if it's helping you, because it will help someone else. And if you're subscribing and the account is not yours, please ask permission from the account holder. I normally write, please follow my notes/scripts. I leave that in the comment section. Okay, like Pythagoras Theorem, for instance, we are doing a lot of squares and numbers, like this is 30.25. So if you hear 30.5, please go by the notes 30.25. Okay. Beware of scammers, please. Beware. Okay. If I have something to say to you, I will say it in the video. If you've not heard it from me, it's not me. I wouldn't be going through the back door, going into your account, asking you for donation for orphanages and sending you foreign accounts. No, it's not me. So beware of scammers. Recap. Our last lesson, we used Pythagoras Theorem to solve some interesting problems involve isosceles triangles. These are triangles which have two equal sides. We've done videos on triangles, so please go and watch if you don't know your triangles, equilateral triangles, all those. We've done videos on them. Okay, watch last lesson video for recap. Okay, now in the starter, I thought I'll bring just one isosceles problem. Okay, now this is an isosceles triangle. Okay, both sides are equal and it has a base. Okay, now here you are supposed to find the height of the triangle. Okay, so you can use this like in a roof, when you are roofing a building. Okay, you can use it, okay, to find how high it should be if you know the length and the slanting distance, which would be the same for a house. Okay, I think one of the videos I will come in, we'll talk about real life problems where you see it in real life as well. Okay, so this is an isosceles triangle. Okay, now we've been given the base. The right angle is here, so we only choose one. One of them, we have two equal right angle triangles. Okay, so we can't use 11 millimeters. We need to use half of it for this, from this part to that part. Okay, that is our A. If we have 11 millimeters, it will give us 5.5 millimeters. Okay, so the isosceles triangle, okay, our Pythagoras theorem is c squared, which is the hypotenuse, which is the part face opposite the right angle triangle, a squared plus b squared. Here our b is our h. So c is 14, a squared is half of the base, which is 5.5, and then we want the height. Now b squared will be equal to 14 all squared. Immediately we move this to this side, it becomes minus 5.5 all squared. So b squared now will be equal to the square root of 14 is 196 if you do it correctly on the calculator. 5.5 all squared is 30.25. Then we subtract, which will give us 165.75. So b squared will be 165.75. b now will be plus or minus square root of 165.75. If you do that correctly on the calculator, b becomes 12.9 millimeters, because our unit here is in millimeters, and it's to 1 decimal place. Okay, you don't need to write 1 decimal place, whatever, but I'm just trying to show you, because we've done videos on this, that if they ask you to leave it in 1 decimal place, this is how your answer will look like. Okay, it will be 13 if it will be the nearest whole number. So b from there to there, which is represented by h in this diagram, is 12.9 millimeters, because the units are in millimeters. So now, even though I found b, the question says h. So I'm going to write h equals 12.9 millimeters, 1 decimal place. Okay. So that is our starter for today. Now today, we will go on exploring Pythagoras Theorem to solve some questions involving squares and rectangles. Okay, you will see this question and then you're like, oh, I haven't been taught, but actually you know Pythagoras Theorem, so you've been taught. Let's look at the square here. Okay, a square has the same size. The corners of a square is 90 degrees. From here to here is the diagonal. So because of this right angle triangle, you could apply Pythagoras to one side of the square. Okay, to find what the side you want. Okay, so let's look at this example. A square has side length of 12 centimeters. Now with the square, all the side, if one is 12, then all the side is 12. Calculate the length of the diagonal. So they want you to find from here to here, which is basically your C. Okay, now you know from here to here is 12, from here to here is 12. So you can use Pythagoras theorem because this is at right angle. Okay, so C squared again will be A squared plus B squared, but A and B are 12. Okay, so and they ask you to find a diagonal. Here it is D. They've given it to you as D. So remember, in the end, your answer should be D, no C. This C squared equals A squared plus B squared is a general formula. Okay, but because you are applying Pythagoras theorem, you are using it. But the question says your diagonal here is D. So after using Pythagoras theorem, leave your answer as D. Remember your units. So now in place of C, I'm going to put D squared. It's a square, so 12 squared plus 12 squared because they have the same size. D squared will be equal to 144 plus 144. D squared will be equal to 288. So D will be plus or minus the square root of 288. When you do it correctly, you are going to get 17 centimeters because our unit here is in centimeters. So D, the length of this diagonal here, is 17 centimeters to the nearest whole number. All my diagrams are not to scale, okay? It's just something I drew on the side to help me answer the question. You can do this for yourself if they haven't drawn it for you, okay? To just figure out how it applies and use Pythagoras theorem to find the side you want. Okay. Another example. A square plot has a diagonal of length 45.6 kilometers. Find the length of the sides. Okay, so here again, we know it's a square, it's a plot, 45.6 kilometers. Okay, so maybe they might want to do some new build on there. Okay, now we know the diagonal. We need to find the side. Okay, but in a square, A equals to B. Okay, so whatever the value of A is will be the value of B. Here again, a square, this is a right angle. Okay, and that's our 90 degrees, our right angle. So for a square now, A will be equal to B. So Pythagoras theorem again is C squared will be equal to A squared plus B squared. But A equals B. So I can put A in place of B or B in place of A. Okay. So C squared will be equal to A squared plus A squared. Okay, because it's a square. So C squared will be equal to 2A squared You remember when we're doing algebra? Now c squared is the diagonal 45.6. So 45.6 all squared will be equal to 2a squared. Now if you do 45.6 correctly on the calculator, you are going to get 2079.36, which will be equal to 2a squared. We go on 2a squared now, okay, will be 2079.36. Now we divide both sides by 2, so a squared will become 1039.68. To find a, it will be plus or minus the square root of 1039.68. If you do it correctly, you come out with a being 32.2 is 1 decimal place kilometers. Because it's a square, if a is 32 kilometers, then 32.2 kilometers. Then b will be equal to 32.2 kilometers as well. Okay, so the square plot have side length 32 kilometers by 32 kilometers with diagonal length 45.6 kilometers. These are some of the questions you see, and then you start panicking. It's like, we haven't done this, but actually you know Pythagoras Theorem. And the only way you can do these things is by being open to looking at some of these questions and thinking. So this is your time now. Okay, I'm just showing you some of the things you can get marks on that you've done. You've done Pythagoras Theorem. You can apply it to solve a question like this. Okay. Then, so that is how you solve a question like that. Now, we'll look at a rectangle problem now, because we've done a square problem. Now you know that with all my diagram again are not to scale. Okay. You know that a rectangle has a longer length and a width. Okay. Or whichever way you think of it. There's a length and there's a width. Okay, now it meets at right angles and it has the diagonal. So if this is my width and this is my length, and they ask me to find the diagonal, I can do that. So this will be like a swimming pool. Okay, and if you swim from there to there, okay, in real life, that is the distance you've traveled. So they can use the length of the pool to measure that distance, assuming you swam in a straight line. Okay, so again, we are going to use Pythagoras Theorem to find this distance, which here is L. So don't leave your answer as C, because Pythagoras says is c squared. You are just applying that. Okay, so here, if this is 10.5 units, then that will be the same. Okay, so I'm going to use this right angle triangle, apply Pythagoras, and find this length, because we are supposed to find the diagonal length. Okay, because I know this side and I know that side. This is Pythagoras. So here L squared, okay, will be equal to 16.3 units. Here our measurement is in units, so we leave our answer in units. 16.3 units all squared plus 10.5 units all squared, because from here to there is 10.5, so from there to there also will be 10.5. So L squared will be equal to 365.69 if you do it correctly on the calculator, plus 110.25. Now if I add them correctly, L squared will be equal to 375.94. So L, our diagonal from there to there, will become the square root of 375.94. So if I do that again correctly on the calculator, L will become 19.4 units, 1 decimal place. The question gave us units, so we are leaving our answer again in units. Okay, so that is an example with a rectangle. Okay, let's look at another example involving a rectangle. A rectangle has a diagonal length of 75 centimeters. So this is a rectangle. Okay, if they give it to you in word form, you can draw a little diagram on the side to see if you can use Pythagoras theorem, or you have enough information to use Pythagoras theorem. Okay, so assuming they just give you the diagram, it will be straightforward and easy. But assuming it is in the word form like this, then you have to draw it and see what you can apply using everything you've learned. Okay, so now this is our right angle at 90 degrees, and that's at 90 degrees. We know the diagonal, we know the length, so we can find this side, so we can apply Pythagoras. Pythagoras again says the hypotenuse, the diagonal, equals a squared plus b squared. So now we know this side from here to here is 75 centimeters. So here our units is in centimeters. So our answer should be in centimeters. Okay. So now 75 centimeters all squared will be equal to 48.1 all squared plus the part we haven't been given the weight. Again, my diagram is not to scale. Okay, I just drew it to explain the question to you. Okay, so b squared will be 75 all squared minus 48.1 all squared. B squared now, okay, will be, if you do 75 all squared on the calculator, it will be 56.25 minus 48.1 all squared will be 2313.61. Now we need to subtract, because for b squared to be on its own, 48.1 all squared have to go to the other side, so it becomes minus here. So we subtract 5625 minus 31, 2313.61. If you do it correctly on the calculator, b squared equals 3311.39. b becomes plus or minus square root of 3311.39. So b equals 57.5 centimeters. The question gave us centimeters for diagonal, 48.1 centimeters for one side of the rectangle. So the other side, which we are supposed to find, which is not to scale, the answer should be in centimeters. So if you do it correctly, you have 57.5 centimeters. Now they said find the width. So you remember, not leave your answer as B. Okay, write width equals 57.5 centimeters, and this is one decimal place. You can also start the question by saying let B equals width and let A equals length. Okay, and let C equals the diagonal. You can start the question by doing that. So in the end, if you leave your answer B equals width, they will still mark you right, because you've told them in the beginning that I'm using Pythagoras Theorem, but to find my length, my width, I'm going to leave my answer as B. Okay, that is another way of also helping yourself, so that in case you don't put it as width, then you are covered. Okay, so now today we've looked at examples involving squares and rectangles. As long as you can see this 90-degree sign, then one thing that should come into your mind is Pythagoras. Okay, so if you read the question and you realize that, oh, what they are asking me, I can use Pythagoras, then you go ahead and use it. But you can only get to this point if you practice, okay, all the time. If you have an exam, then you should practice, okay. I remember when we were in school, every morning we had maths. Okay, we had maths, we had mental, maybe we had PE. If we didn't have maths, we had PE before maths. And then in the afternoon, it is for reading and comprehension and grammar and spelling and stuff, and some science. Okay, now because of, I don't know, maybe because of the number of students, the school is not able to give that, but you can come home and dedicate a bit of your time to looking at math questions, and maybe for maybe like 30-40 minutes, and doing some reading or doing some science work. Okay, that is another way of helping yourself when you come home. do a little. I can't say and don't do social media stuff, but it shouldn't take your whole evening texting people, because at the end of the day, if you are going to write an exam and you are on the phone texting people, how are you helping yourself? Okay, even if you're not doing an exam and you have something to do the following day and you are doing that, you are not helping yourself. So if you want to be successful, yes, all work and no play is not good, and no play and no work is also not good. Okay, but you can structure yourself such that, oh, I'm going to do 40 minutes of math or watch a video for this length, answer a question, and I'll reward myself going on social media for 15 minutes and having maybe a chat, or 30 minutes watching a few funny stuff, and then have a good night's sleep and get ready for the next day. And I can assure you, if you do that, you'll be very successful. Okay, thank you very much for watching our video today, and I'll see you in the next.